Hello everyone, welcome to my channel. This is the second part of the first chapter, Matter in Our Surroundings. So today we shall learn the effect of temperature on motion of particles. So the motion of particles we all know increase with respect to temperature. So definitely temperature is directly proportional to motion of particles. As you can see in this bracket, I have written kinetic energy. What is this kinetic energy? Kinetic energy is the energy required for motion of particles. So if we increase this temperature, the motion or movement of particles will increase. So basically when we increase the temperature, we are increasing kinetic energy. So when we increase the temperature, we are basically increasing the kinetic energy, or precisely if we say that we are giving energy to the particles to move from one place to another. So this is a simple experiment which you can conduct in your house. See, cold water and hot water. Again the same experiment. I am adding few crystals of potassium permanganate to this cold water. You can carry out this experiment by using ujala also at your house. You can add 2 to 3 drops of ujala at the surface of water and you can see the result. So in the cold water, we will see that the motion or movement of the particles, or precisely to say the color will not get discharged into water more easily in compared to hot water. That is, when we add potassium permanganate or ujala into hot water, due to the temperature is high, as the temperature is high, so the motion of the particles is higher. So definitely when we add this potassium permanganate crystals, the particles, as soon as it gets into the hot water, it will gradually move faster in compared to this cold water. Now this is the definition of diffusion. The movement or mixing of different particles among each other to get mixed uniformly is called diffusion. Now this term is very important, uniformly. As we know, when we add this potassium permanganate or ujala, a time comes when the entire water gets colored. The entire water gets colored. So diffusion is a process in which the movement or mixing of different particles among each other to get mixed uniformly. That is, uniform distribution occurs. Particles of matter attract each other. As you can see, some pictures are here. These are nails and these are chalks. So particles of matter attract each other. Now suppose I have taken a hammer and I hit the same hammer on these nails as well as on these chalks. So it is quite obvious by your experience that this chalk will easily break down. This chalk will easily break down by just one hit of the hammer. But in this case it will not happen. Why? This is the reason that particles of matter attract each other, due to the force of attraction. So the particles of these nails are tightly held together than this chalk. The particles of these nails are tightly bound or are held together tightly. That's why on hitting the hammer, it will, directly hitting the hammer on these nails for one time, it will not break it. But in case of chalk, it will easily break it. Similarly, as you can see here, moving hand through water and moving hand through air. This is our common experience, because we can move our hand in air easily, but in case of water, the particles of water are held together more tightly in compared to air. That's why we face little difficulty in moving hand inside water. two types of forces of attraction. One is cohesion, another is adhesion. So as you can see, this is the water molecule H2O. We all know that formula of water is H2O. So as you can see, this water molecules and these are the walls. Actually, when we keep water into a beaker or any glass, what happens? We can see two types of forces. One is cohesive force or cohesion, that is, by the definition you can see, force of attraction between same substances. So in case of water, see, this is cohesion, that is, the water molecules are stick together, or water molecules hold each other through this cohesive force. But these water molecules also hold this glass surface tightly. This is called as adhesion. So adhesion is the force of attraction between different substances. Why different substances? Because one is water, another is glass. In cohesion, why same substances? Because both are water molecules. Okay. Now rigid versus fluid. Then the term only explains rigid versus fluid. Rigid means inflexible or not flexible. Fluid means the property to flow. So we all know that solids are rigid because when we, as you can see the diagram, that when we put a solid on a floor, suppose a pencil when you put or keep on a floor, definitely it do not starts flowing, right? Or a cube of or a Rubik's cube, if you keep it on table, it do not show the fluidity property, or it do not flow. But in case of liquid and gases, it flows from one part to another. Like water, when we drop it on floor, it have the property to flow. Similarly, in case of gas, when we lit an agarbatti, definitely the gas flows from one place to another. So these are the properties. One is fluidity, another is rigidity. Now states of matter. So states of matter and phase transition, or changing of one phase or one state to another. So as you can see, this is an example of water in its three states. What are these three states? The solid state is ice, liquid state is definitely water, and gaseous state is water vapor. The gaseous state is water vapor. So as you can see, solid to liquid change is melting, liquid to gaseous change is vaporization. Again similarly, if we reverse back, from gas to liquid is condensation, gas to liquid is condensation, liquid to solid is freezing. Now one important phenomena that we can see, that solid directly converts to vapor. Like common life example, naphthalene, camphor. When we keep in open air, a time comes when we can see the entire solid has been evaporated. That means they have changed to this gaseous form. Again, to convert this gaseous substance to this solid is called deposition. Now these are few properties of solid, liquid and gas. So in case of mass, both solid, liquid and gas have definite mass. In case of shape, we all know that solid have definite shape. Liquid, it acquires the shape of the container. In case of gas, acquires the shape of the container. That means in which container we will keep, it will take the shape of it. Volume, solid have definite volume, liquid also have definite volume, because when we transfer a 100 ml of liquid or 100 ml of water from that beaker to any jar, the shape will change but the volume will remain same. But in case of gas, the volume is indefinite. This we will learn in the next pages. Compressibility, not compressible, almost negligible, and in case of gas, highly negligible. Fluidity, as we have discussed in the previous page, they are rigid, so they will not have the property to flow, but liquid and gas can flow. Rigidity, solid is highly rigid, liquid is less rigid, and gas are not at all rigid. Diffusion, solid slow, liquid fast, and gas very fast. This also we have discussed. Because suppose in case of solid, suppose we are keeping a stone on our study table, will we can see that, or can we see a perfect diffusion? No, because in compared to agarbatti, when we lit an agarbatti in an entire room, the diffusion can be seen, as we can see the flow of the fluidity property of the smoke in the entire room, but this is not possible to see in case of the solids. Space between particles, more closely packed, less closely packed in case of liquid, and least closely packed in case of gases. Interparticle force, or basically the force of attraction, definite, slightly weaker than solid, negligible. The example that I have given in the previous, here the movement of hand in water will be less easier in compared to air. Now in case of solid, suppose in case of solid we are trying to pass our hand through a wooden plank, so definitely it will not allow our hand to pass through it. We will hit our hand, okay, and we will get hurt. But in case of liquid and gas, we can, in case of liquid, due to less force of attraction in compared to solid, we can move our hand quite easily in compared to solid. And in case of gas, the obstacles are quite less due to the less force of attraction. That's why we can walk, we can freely move our hand in air. So this is the property, or these are the properties of solid, liquid and gas. So thanks for watching. I will share the third part of the video very soon.